In this example, we are going to apply the idea of voltage divider using numbers. Simply, we have again a setup very similar to what we have seen earlier. Two resistances R1 and R2 are in series, and they are connected to a 75 volt voltage source. Okay, we are simply asked to find out the values for V1 and V2. Before we get into the math, let us try to give the intuition, let us try to apply the intuition that we saw earlier. There are two resistances, obviously. R1 is big, which is 2 kilo ohms, and R2 is comparatively small, it's only 500 ohms. So if you remember, the voltage dropped V1 by the bigger resistance is greater than the voltage V2 that is dropped across the smaller resistance. So a quick sanity check when you do your problem is to remember that you should see a bigger voltage drop V1 compared to V2. Okay, so let's see if we can do the math. Okay, now V1, if you remember the equation that we just derived earlier, right? V1 is Vs by R1 plus R2 times R1. That's this guy. Okay, so let's apply that. V1 is the voltage source Vs divided by R1 plus R2. Okay, so that's V1. So you can see that voltage source is 75 volts. And let's not forget this multiplied by R1. Remember, the voltage 1 is proportional to R1. Okay, that's the formula. And the idea that we want to remember is that bigger resistance drops bigger voltage. And let us verify if the numbers bear that out. R1 is 2 kilo ohms and R2 is 500 ohms times 2000. Okay, so you can see that this is 75 divided by 2500 times 20 or 2000. Okay, you do the math, you will see that this comes out to be 60 volts. Okay, so V1 is 60 volts. So that's one of the answers. Okay, let's calculate V2 as well. The same idea, V2 is Vs by R1 plus R2 times R2, right? So we can plug the numbers in. 75, that's Vs, right? The source voltage, remember, Vs. That's 75. That's where I got that number from. Okay, so 75 volts by, again, this is R1 is 2K plus R2 is 500 ohms. All of this multiplied by R2. Okay, you will see that this number comes out to be 15 volts. Just plug these numbers into a calculator. You'll see that this is 15 volts. So V2 is really 15 volts. That's our other result. Okay, so let's copy both of these, or let's plug them in here. Okay, V1 is 60 volts, V2 is 15 volts. Remember, we started out by the hypothesis that V1 should be greater than V2. V1 is dropped by the bigger resistance. Bigger resistance has a larger voltage drop, compared to the smaller resistance, which has a smaller voltage drop when they are both connected in series. Okay, so sure enough, we have our V1 to be 60 volts and V2 to be 15 volts. Okay, now what is really interesting is, and this is just a pretty straightforward problem, what is really interesting is, look at the relative values of R1 and R2. R1 is 2K and R2 is 500 ohms. So one is really R1 is 4 times as large as R2. And if you compare V1 and V2, it turns out that V1 is actually, it has the same ratio with V2 as R1 has with R2. Okay, so that's the idea of voltage divider. R1 by R2 is the same as V1 by V2. That's something you can use to do a quick sanity check when you're working on problems like this.